I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 1st.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. All right, let's get to work. And Happy New Year. It's good to see you. All right, it's going to be a better year than years past, and we're looking forward to it. And we have a lot to talk about. Let's get into it. We'll start by looking at significant wave heights in the North Pacific Ocean, and sure enough, we have a gale in the Gulf of Alaska. Previously, it was over the dateline, still generating, 25, 26-foot seas, something like that, but fading. It was in the 29-foot range earlier. Definitely, it has produced swell. That swell is pushing, as you can see, towards the Hawaiian Islands and the U.S. West Coast. A one in many of a series of storms that have happened, and many more to come. Can't be much better. But first, we'll do a quick look at current conditions. We'll start up in Northern California. Point Reyes buoy, 029, CDIP buoy. We're looking at all the energy present at the buoy from way up to 33.3 second period, really long period energy. And there's, a tenth of a foot there? Probably most of that is not legitimate. Most energy somewhere in the 14 second period range with another big bump of wind swell in the 9 to 8 second period range. You integrate all this together and you see a primary swell 7 feet at 13.6 seconds from the west, 272 degrees. That produces surf at theoretically 9.5 feet on the face, and that's maybe a little overshooting it. And there's secondary swell, 7.6 feet at 9.7 seconds. Pure wind swell just mucking all this up and creating a jumbled, ugly mess. Winds were nuking very hard northwest earlier today. They're settling down some this evening, but still pretty much a jumbled mess. We'll go down south looking at the Point Loma South buoy, buoy number 191. That's off of San Diego. Again, all the energy present there. We see mainly wind swell in the 9-8 second period with some secondary swell sneaking in through the islands, the Channel Islands, from the west. Let's look at this actual primary swell, 9 feet at 9 seconds from 281 degrees, pure wind swell, theoretically 8 feet. That's probably overstating it quite a bit. Secondary swell, 3.5 feet at 12.3 seconds from 257 degrees, kind of getting warped a little bit there by the islands. And the swell from that, or surf from that, about 4.3 feet. That's about right. And then finally we go to the north shore of the Hawaiian Islands, Waimea Bay buoy number 106. Again, a little bit of swell, not nearly as much. Things settling down there. The focus seems to be turning towards the East Pacific, the Gulf of Alaska and into California, certainly judging by the amount of rainfall that's been happening north of Point Conception the past couple of days. That seems to be the case. Anyway, a little bump of energy there in about the 12 second period range with straggler bits of energy out to even theoretically 20 seconds and a bunch of wind swell down to 5 seconds. Put it all together, biggest surf, 3.7 feet at 12.6 seconds from 311 degrees. That's about 4.6 feet Hawaiian, maybe head high on the face, something like that. And then there's some secondary swell in there at 1.6 feet at about 16 to 17 seconds. Good for waist high or so. That seems about right too. All right, so what's going on? We're going to start up at the jet stream level. Jet stream level winds up about 30,000 feet. These winds help support the formation of gales. When the gales form, help direct their track. We have a very impressive jet. Look at this, just 180, 190 knots, maybe a little bit less in pockets, running flat across or straight across the Pacific on about the 35 north latitude line. We've been waiting for something like this for a couple of years now. Finally, we have it. What is causing this? It is right down here in this area. Westerly anomalies that we've been talking about for months now have finally, you see the West Pacific, well, it really starts here about 120 east, but we normally say about 135. But in this area right in here on the equator, the winds are turning more westerly, and that imparts energy to the jet stream, and the jet stream, as you can see, is responding just as one would expect it one, just raging across. Okay, so the jet stream, what we're looking for is a trough, a dip in the jet. There's sort of a weak one there. That helps support a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And if low pressure is strong enough, of course, it generates winds. Winds, as they get traction on the ocean surface, generate seas. Seas, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach like Hawaii or the U.S. West Coast, creates surf. So we have a raging jet stream, very capable of supporting gale development. We don't have a whole lot of troughs. There is actually a trough pushing into California as we speak. This is what's been responsible for just major inundation of precipitation over the past 2 days. The rain gauge out back, I cleared it out before the storm. In a little over 24 hours, it filled to the top and overflowed. That's about 5.5 inches. San Francisco reported beating, I believe, its all-time record of somewhere like 5.25 inches in a 24-hour period. That's from midnight to midnight, and that was yesterday. That's an immense amount of water in a very short period of time. Just looking at snowfall accumulations up in the Sierra, the equivalent of about 2/3 of a regular season's worth of snow has now fallen on the Sierra. And the same thing precip-wise, about 2/3 to almost pushing 3/4 of the amount of normal precipitation we get, at least in the Bay Area, has fallen already. All right, we're diverging a little bit. What are we looking for? Well, a trough. We're into Monday, a little bit of a trough north of Hawaii, and that starts digging out. Definitely, there is a clear trough as we get into Tuesday night and Wednesday. A significant storm is forecast very close to the coast. That should result in large surf. We'll get into that in a minute, but you also see the jet just plowing right on shore over central California into southern California. They'll perhaps get a taste of the wet weather action. Look at that. Even as we get into Thursday night and Friday, the jet just pushing right in there. Jet back to the west, continuing to rage. 180 to 190 knots. Another trough digging out as we get into Friday and Saturday. Again, very close to the coast. So whatever break there is in the weather right now, better make the most of it, because it sure looks like it's just more to come. Another trough here off of the Kuril Islands as we get into Sunday night, a week from now. Another big trough in the Gulf and energy pushing in. You get the general idea. It's just all heck is breaking loose, and it's kind of what we've been looking for. I mean, the other day I was almost complaining, saying, gosh, I wish the rain would stop, and then I caught myself. But when this is all over, I suspect that's exactly where we're all going to be, looking for a break in the action. All right, let's go to look down at the surface. Surface level pressure, surface level winds. There is a gale up in the Gulf, northern Gulf of Alaska. We'll get in when we get into the Hindcast wave models. You see where it started. It still has a little bit of fetch, 30-knot fetch, and it's producing, what would we say, 25-foot seas up here. And swell from it is approaching Hawaii and the U.S. West Coast. That one fades out. But right here, as we get into Tuesday, the 3rd of January, another storm starts building off the U.S. West Coast with 55-knot northwest winds. At one point, I saw a model, there it is, 60-knot winds. That's approaching hurricane force. 65 knots is hurricane force, pushing right to the east, virtual fetch, building up likely some large seas. You see the front just slamming into the coast from Point Conception northward. So we get into Wednesday, and maybe the tail of it reaching down into Southern California on Thursday. A lot of fetch, and look at this, just more stacked up right behind it. So we get into Friday, here comes another one, not as big, probably good news, but producing another front pushing into California, another low building on the date line on Friday night into Saturday. It winds up pushing towards the coast as well. You know, we really want these to sit further off the coast, about no more, getting no closer than 800 miles, somewhere out around here, but they're all coming in closer than that. Another system also on Saturday night, the 7th of January, developing off Japan. You get the idea here. 60-knot winds, Hawaii. If this materializes, you think Hawaii is going to get some swell? For sure. U.S. West Coast more. This is what we've been waiting for for 2 years now. It appears the dam has broken. Westerly anomalies are pretty much causing the complete collapse of La Nina. We're back into a normal weather pattern. We were actually thinking this wasn't going to happen until, what did we say, maybe late January, early February. We beat that by a month. We'll take it. This is all good news and a great way to start the new year. Next up, significant wave heights for the North Pacific Ocean. We're going back in time to Thursday, the 29th of December. Little gale started developing. This is more of a primer gale. This is more of the main event Friday out by the date line. Seas building to 27 feet, 28, 29 feet on Friday night. And then on New Year's Eve, 28-foot seas pushing over the date line. Clearly, swell is being produced. It is radiating, that gale now, of course, in the Gulf of Alaska, radiating towards Hawaii and the U.S. West Coast. Let's go look at the future. All right, looking forward, you can literally see the swell front hitting the Hawaiian Islands on Monday, approaching the U.S. West Coast and slamming into it later on Monday into Tuesday. The real issue is conditions, certainly on the U.S. West Coast, with the jet pushing right over California. That typically doesn't bode well for calm winds, light offshore winds, that sort of stuff. But maybe there will be a couple little windows. All right, next event, the storm on Wednesday starts winding up as we get into Wednesday morning. There we go. We'll pull this down. Peak seas. 46.2 feet right there, wind 61 knots, and that's only, maybe 800 or 900 miles off the coast. So probably more of a concern, at least north of Point Conception, from a property damage perspective if you live on the coast. I mean, with strong winds, giant seas, not really a surfing event. Now, the good news is it's fairly far to the south. Southern California, folks there have been patiently waiting their time for some real swell. This looks like a prime opportunity. Look at it. Actually, let's go back and check out the seas on that one. 45 feet. So pretty much a whole day of 40-foot plus seas, right, aimed well at the coast, but a little bit too close. All right, moving on. As we get into Friday, now it's just little spurious gales all over the place, but another one winds up with like 33-foot seas on Saturday off the coast. Another one pushing over the date line with 26 or 27-foot seas, and then metastasizing into a gale with, let's see what we got there, 46 feet. Now that's, again, the model's probably overhyping this a little bit, but you get the idea, and we're almost a week out, so don't know if that's going to really happen. That storm that was forecast just off of California, it was on the charts a week ago. It fell away and disappeared. Now it's back. This one probably will disappear and then reappear again somewhere the middle of next week. And yet another system developing on the date line with 40-plus foot seas. It looks like we are in the gravy train for surf here. It's just a matter of getting out of the wind. So let's zoom in, take a little look at California right here, Hawaii down here, looking at winds today. Yes, it was definitely a north wind blowout mess. Northwest wind, full-on whitecaps along the central North California coast. Why? With light trades. So we get into Monday. Here comes the next front, queuing up a little window there. But the sea state is so agitated that, 6 hours of slack winds is not going to do much to alleviate what's probably a base state of 6 to 8 foot, we'll say 8-second period wind swell coming from the south. It's going to take a lot more than that. Anyway, on Monday, Hawaii still in trade mode. South winds, U.S. West Coast. Tuesday, more south winds, a little bit of a pocket here, maybe Tuesday morning, something like that. But then here comes the next front. You can see it right there with a big low winding up. Hawaii has about a day or two of northeast winds, probably a little bit lumpy and ugly. And then look at this monster storm theoretically lined up off the California coast with 30-plus, 35-knot south winds on Wednesday. Hawaii still having a little bit of issue with the northeast winds, but as we get later in the day, those winds start turning more to trades as the front with 30, 35, 40-knot wind slams into central and northern California. You know that's going to be a weather event for sure. Thursday, things settling down, but look at this, just nonstop westerly fetch for, well, it's 1,800 miles out to Hawaii, or 16, something like that. So you get the idea. The whole ocean just plowing off to the east. Hawaii sitting nice and protected with their mini dome of high pressure here, not having to worry about the onslaught. And here we go again on Friday. South winds, another storm queuing up. Hawaii under the influence of trades. You get into Saturday, boom, here we go. Now, Southern California, of course, more protected. It's north of Point Conception that's really the concern in terms of weather and south winds. Then we get into Saturday and Sunday. You get the idea. It's just perpetual south winds north of Point Conception. Hawaii's sitting comfortably with light trades, so you kind of get the idea where you need to be. When it rains, it pours. Well, you heard the story about San Francisco and how much rain we got, and that is not the end of it. As we get into Monday, next band of rain pushes into the coast, even down into Southern California, snow in the Sierra. On Tuesday, things clear out for just a little bit in the morning. By the afternoon, south winds, you can see there's just the isobars pushing up the coast. Now, the real event rain-wise doesn't start till maybe Wednesday about 10 a.m., something like that. Snow starting to build in the Sierra, probably pretty high snow levels. But then as you get into Wednesday afternoon, it's just a blizzard, basically, with a mega front draped the whole way from Hawaii right on up into California. That does not look pretty. It looks like a major wind and snow event, and some of the rain working its way, or even a pretty good pocket there, into Thursday for Southern California. We get into Friday, things clear up just for a moment, and then boom, here we go. The next event trying to push in, not looking. It's sort of a double fake. It fakes itself out, and then the real event comes in on Saturday with more precipitation, more snow for the Sierra. Sunday, that fades out. Next one queues up, and here we go. If you ever wanted a weather machine, this is it. It looks like it's honestly going to be too much of a good thing, but you take what you can get. So we also have gotten reports from Australia. They were getting inundated all during La Nina. Now the past 2 months, the rumor is, or the word is, that things are drying out there significantly. And it's like someone just flipped the switch. We went from them getting pummeled in a La Nina situation to now the U.S. West Coast getting pummeled in a semi or maybe developing El Nino situation with Australia starting to dry out. Snow forecast dashboard for Palisades, Tahoe, formerly Squaw Valley. You can just see steady build up, not as off the charts as what we were seeing, but still 60 inches on top of whatever they got. I think it was 35 inches from the last storm, and I think that was in like a day or two, something like that. Again, they're up to, I thought it was around 225 inches of total snow has fallen so far this year, and we're not even really into the ski season yet. It's not till about January 15th, and typically I start waking up to it. Anyway, their normal average snowfall is like 350 inches, so they're 2/3 into their normal snowfall. And then here we go, another 5 feet forecast. Let's go check out some other resorts. Sugar Bowl looking at about 5.5 feet. Kirkwood at about 4.5 feet, and Mammoth with about 2.5 feet. Looking at snow levels, a little bit better picture. The last big storm was snow levels really high. It was nearly raining, I believe, up at the top of Squaw at 8,900 feet or something like that at one point. It quickly crashed down to the base. So this is the base of Squaw at 6,200 feet, and the summit about 9,000 feet. So the next storm, you can see the yellow lines here, or we could actually sort of do it this way. There you go. You can see where the blue is the actual snowfall. The red is the accumulation of all these little bits of snow. You can see the snow level, for the most part, is going to be below the base, other than this event on the 4th. It's mainly on the 4th, where the snow level, the white is freezing, the blue is much colder, the gray is sleet, The red is liquid precipitation. So snow level about 7,000 feet during the morning of the 4th through the day. But then after that, falling down for when we get into the bigger snow, it's all down at around anywhere from, let's say, 4,500 to maybe 6,000 feet, something like that. So a much better temperature profile for snow production than the last big storm. All right, let's go take a look at long-term. What's going on with the Madden Julian Oscillation and the El Nino Southern Oscillation? These two oscillations are the major determiners of weather and potential for surf and rain long-term in the Pacific Ocean. We'll start by looking for signs of the active phase of the MJO, the Madden Julian Oscillation. It has two phases, active and inactive. One phase is on the one side of the planet, the other on the other. They rotate west to east around the equator. The active phase is what we're looking for. It is effectively a low-pressure system, and when it crosses or makes its journey across the Pacific, takes about 6 weeks, something like that. It imparts energy to the jet stream, especially when it's in the far west Pacific. And that, of course, feeds storms and production, gives us snow and rain in California. The inactive phase, the exact opposite thing. It's a high-pressure system. Oh, and the active phase, it can dampen trade winds, and that's what actually helps impart energy to the jet stream. The inactive phase does the exact opposite. It's a high-pressure system, steals energy from the jet stream, tends to dry weather out across the Pacific, and is not great for surf or snow production. All right, so we're looking at data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino, but they also can give us clues on the MJO. We're just looking at the arrows, wind speeds. These are trade winds. You see, the longer the arrows, the stronger the wind. So pretty strong trade winds in the East Pacific, strong trade winds in the Central Pacific, and fairly strong trade winds in what we call the Kelvin wave generation area. The date line is right there. That's the equator right there. That is New Guinea there. But it's not the actual wind speeds. It's the anomaly, differences from normal for this time of year. You can see trades pretty much dead normal over in the East Pacific. Same thing in the Central Pacific. A little bit stronger than usual here, right on the date line. What has happened, though, the sensors over here, these are the ones we'd really be interested in, because this is where all the models are saying westerly anomalies are happening from about 150 and points west of there. Well, those buoys and the sensors are all down, so we can't get any data there. But over the date line, suggests moderately stronger than normal easterly trades. So can't really tell too much from here whether what's going on from an MJO perspective. Let's go look at the forecast for the next week. Actually, before we do that, here is 850 millibar zonal wind anomalies, the east-west component of the wind, South America there, Central America. 0 is the equator. Dateline right there, the maritime continent there. And the reds, you can look at the arrows out of the west. This was on December 26. You see just this sort of persistent pool of westerly anomalies over the maritime continent, trying to work their way into the far west Pacific, somewhere to about, well, that's about 150 right there, maybe 140, something like that. So in the far west Pacific, it looks like this persistent westerly anomaly wind pattern is set up. We'd say that's the active phase of the MJO, and we think that is what is feeding energy to the jet stream and creating the weather that we've been seeing of late. So here's the forecast, 850 millibar zonal wind anomalies. That's up about 4,700 feet, but a good proxy for what's going on down at the surface. This is the east-west component of the wind. The purples, the blues, those are easterly anomalies, enhanced trades. The reds and yellows, westerly anomalies, suppressed trades. Now, this is the whole plan on one chart. The date line runs right up the middle here, so you can see easterly anomalies on the date line, but the West Pacific starts somewhere around 120 to 135, something like that. And you can see westerly anomalies starting December 17th work their way into what we call the Kelvin wave generation area, the far West Pacific, because that's where if you get west anomalies there, that creates Kelvin waves, a ball of warm water that can be pushed by these westerly anomalies across the Pacific under the equator, okay? If you have successive active phases in the MJO or just a bunch of westerly anomalies, sort of what we're starting to see, you get successive Kelvin waves. Successive Kelvin waves, eventually they erupt at the Galapagos and off of Ecuador and start warming surface temperatures there, and that is how you can kick off El Nino. So that's why we are very suspicious and very carefully monitoring this area, because what was westerly anomalies over the maritime continent producing all that rainfall for Australia is now shifting into the Pacific. A dryout is starting for Australia, and the suspicion is multiple Kelvin waves could result, which could push us into El Nino. Now, for the next week, only 7 days, well, we have this same pattern of westerly anomalies, making it about halfway through the Kelvin wave generation area. 170 west is what we consider the far eastern extent of it. So it's right in this area that we're interested in. So it's sort of a La Nina easterly anomalies holding on the date line, El Nino-ish westerly anomalies trying very determinedly to make their way into the West Pacific to just put a death nail in the heart of La Nina. We hope it happens. Let's keep digging. Let's look 2 weeks out. Outgoing long-wave radiation. Fancy words for cloud cover. What are we looking at here? Well, there's South America, Central America, Hawaii, New Guinea, EQ. That's the equator right there. Dateline right there, 180 west. Kelvin wave generation area right here. We'll say from about 130 to 170 west, right in there. When you get westerly anomalies in here, that's where you get Kelvin waves, and that's what we're very interested in, because that gives us clues that maybe El Nino is developing. All right, so this is the statistic model, right? This is not winds. This is outgoing long wave radiation cloud cover. The blues, all this means is more clouds than normal. The oranges, less clouds than normal. So that would be the inactive phase of the MJO. That would be the active phase of the MJO. This model suggests active phase starting to move out of the Kelvin wave generation over the next 5, 10, 15 days, with the inactive phase of the MJO moving over the Kelvin wave generation area. We don't really want to see that. Now, the dynamic model paints a much rosier picture, suggesting, no, the active phase of the MJO just sort of holding, producing clouds, and one can assume westerly anomalies in this area. That's what we want, because that ensures a continued flow of energy or enhancement to the jet stream, just like what we've been seeing. And that, again, feeds storm production and produces surf and all the things that we as surfers and ocean people are very interested in. Unless you're out there in a small boat and you're trying to fish, then you don't want any of this. All right, phase diagrams for the same two models, statistic model and dynamic model. These just show where the active phase is and how strong it is and where it's going to go in the next 2 weeks. The MJO, how do you read this chart? Well, the MJO moves from west-east, from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is. The further away the dot is from the circle, the stronger it is. So that's a pretty, we'll say, weak to modest active phase of the MJO right now in the West Pacific, exactly where we want it, in the Kelvin wave generation area. According to the statistic model, it's supposed to race and be over Africa and pretty weak 2 weeks from now. Now, the dynamic model, look at this, and maybe we can squeeze this over here a little bit so you can see it better. Suggests the active phase moving maybe to the East Pacific, but then just sort of ping-ponging around there and still weak, but that would be effectively where California is. And if you think the storm pattern's bad now, this is 1, 2, 3, 4, so pretty much like what the other models are suggesting. A week from now, just a hectic storm pattern and wet weather and unsettled conditions for California. I guess that's a good thing, seeing how we're in a drought, but at some point it will be too much of a good thing. All right, so then we look at the CFS model going out a month from the 31st of December to January 28th. Again, whole planet on one chart. This is the east-west component of the wind. The blues are the easterly anomalies, the reds, westerly anomalies. The dark contour, the filled-in contour, is the active phase of the MJO. the dotted contour is the inactive phase of the MJO. Now, this is past performance. You can see steady easterly anomalies have persisted on the date line right there. Okay, and westerly anomalies, for the most part, have been over the maritime continent. But you see, as we get into December, they're making, well, there's even a little push in November there, a Kelvin wave pushed across. Now you see westerly anomalies made another push across in early December, and then building stronger. And here is the active phase of the MJO. Right now, pushing into the Kelvin wave generation area, with westerly anomalies forecast to encroach not quite to the date line, but a pretty good push. I mean, considering where we've been, this is a big deal. In real El Nino years, you'd see these westerly anomalies go the whole way across the Pacific, but anything is good news. So we're supposed to see that in the next week. Westerly anomalies persisting. Now look at the easterly anomalies fading, getting weaker and weaker. They still hold their coverage, but here's that dividing line. Half the Kelvin wave generation area starts right there, and it's over here. About half of it filled with westerly anomalies into mid-January, and then we go to a neutral pattern, and then a little bit of hint of westerly anomalies rebuilding. But the real point here is the easterly anomalies, which have been so strong, basically, in about a week and a half, they just lose all their mojo, and it sure looks like they may not come back. And then the CFS model going out 3 months. Now, we don't believe a model going out hardly a week, much less 3 months. But this model has been consistently suggesting that a major change is underway. And from everything we can see, yeah, it's not evolving as strong or as clear-cut as what the model suggests, but clearly something major is changing, and this model, for all intents and purposes, has done a reasonably good job. So what are we looking at here? Again, whole planet on one chart, date line runs right up the middle. Kelvin wave generation area starts somewhere around here. The forecast is up here. What has been is down here. You can see this clear pattern. This is east-west component of the wind. Westerly anomalies, these yellows, you see that they were all over the maritime continent, like 90 east. And then steadily, little bit over the time, you want to see what has actually happened. You can see westerly anomalies encroaching into the Kelvin wave generation area, and the model has that continuing to happen, eventually filling the entire Kelvin wave generation area as we get into March. Now, not with super strong winds. Also notice easterly anomalies forecast to build over the maritime continent, where previously it was all westerly anomalies. This all smells like this is the La Nina pattern down here. This looks like an El Nino pattern. All right, so let's overlay the MJO just for fun. What do we got? The solid contours of the active phase of the MJO. So active phase of the MJO pushing across the Kelvin wave generation area from now into about the end of January, maybe the early part of February. A little bit of a very weak inactive phase of the MJO, but westerly anomalies supposed to persist, and then continue working their way across. What is driving this? Well, we'll pull up the low-pass filter here, and it clearly indicates what's happening. The dotted contour here, in fact, we could take these other guys out of here just for a second. The dotted contour is a high-pressure bias. Consider that the La Nina signal. Back in September, locked right over the date line. What's happening as we get into the early part of February? It pretty much, the second contour dies. And the primary contour, the last contour, as we get towards the end part of February, it's almost completely out of the Kelvin wave generation area east of there. The low pressure bias, this is the high pressure bias, this is the low pressure bias, the El Nino indicator has been sitting over the maritime continent, 90 east like we were talking about, but starting about the mid to end November, you can see the line starting to creep off to the east, and it's supposed to continue creeping east and filling, well, let's see, there's it's almost halfway through the Kelvin wave generation area by the time we get to the end of January, and by the end of March, filling the entire Kelvin wave generation area. This looks very much like a developing El Nino pattern, especially when you see, well, that low pressure bias is what's driving the westerly anomalies to encroach into the Kelvin wave generation area, which in turn can likely, when paired with the active phase of the AMJO, can produce a Kelvin wave, or just if not a Kelvin wave, a steady flow of warm water in the West Pacific to the east. That's exactly what we want to see. All right, what's going on in the ocean? We've been talking about Kelvin waves. Can we see one? Do we have any clue that there is something happening? All right, so we're looking at data again from the TAO buoy array, that series of buoys used for monitoring El Nino. They are anchored. These are the anchor lines on those buoys, and there are sensors on those anchor lines, water temperature sensors. So you can get a profile of where the warm and cool water is in the Pacific, right on the equator, 5 degrees north, or in this case, 2 degrees north to 2 degrees south, just a thin little band. It is that area. I mean, just 10 degrees, 5 degrees north and south of the equator across the whole Pacific. When changes happen there, that affects the weather pattern for the entire planet, and in incredibly big and meaningful ways. So we spend a lot of time watching that. All right, so we're looking at the 29 degree isotherm. That's 29 degrees centigrade. It is not there. My guess is it was here last week for a couple of days. My guess is it's sort of balled up here, but again, these sensors are all down here, so you can't really see what's going on. 28 degree isotherm. It was over at about the date line 2 weeks ago or something like that. It's backtracked a little bit. 26 degree isotherm. It's been ping-ponging somewhere around 150 to 158 for quite a while now. But, and neither of these are indicative of a major push of super warm water, but the 24 degree isotherm was like locked at 130, fully now pushing into the East Pacific at the surface, suggesting surface temperatures are warming in the East Pacific. But it's not the actual temperatures, it's the anomalies, differences from normal for this time of year. And a very clear and obvious pattern is emerging here. Warmer than normal water, 4 degrees, 3 degrees Celsius, that sort of thing. So that's, 6 or 7 degrees Fahrenheit. Big ball of warm water has pushed the whole way across the Pacific, and theoretically, according to this, is at, 105, probably 100, almost the whole way to the Galapagos, and no sign of cold water. La Nina would have cold water all in this area, and we've been looking at these charts for 2 years now. You're pretty used to seeing that. It is nice to see, driven by westerly winds, westerly anomalies here in the West Pacific. That'd be like right here. Westerly anomalies driving warm water to start migrating subsurface, not here at the surface, down here, in the form of a Kelvin wave, and looks like it's likely to be impacting Ecuador pretty soon. Here's another view of that. A big, huge ball of warm water, making it to about 150 west, but look at boom, 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 pockets of warmer water also making their way into the east. The last residuals of La Nina's cool water here, but getting squeezed to the surface, and once they're gone, there's nothing but a flood of warm water behind that. It also looks like cool water here above the Kelvin wave in this area is breaking up, getting warmer, however it's happening. But this is about a week behind what we saw at the previous one, so we think this situation is even more entrenched than what it shows here. Sea level anomalies. This is satellite data. These are not temperatures. This is the height of the ocean. If you strip out the wind waves, the swell, the tides, and we're just looking at the sphere of the ocean, is it higher or lower than normal? And what does that mean? Well, if you have cold water at depth, cold water contracts and it'll create a divot on the ocean surface. Warm water will expand and create a bump on the ocean surface. So this is change, or the difference in the ocean surface compared to normal in centimeters. So 5 centimeters, 15, 20. Okay, and that is New Guinea there. There's the equator. South America, that'd be Peru and Chile. Central America, Hawaii there. Dateline right there. See this giant, massive area of warm water driven by trades for 2 years, all balled up here in the West Pacific, just waiting for a break in the trades, which we think is happening now, a active phase of the MJO can dampen the trade winds, and boom, some of this water, a little bit of it will spurt out and start rushing off to the east. That's a Kelvin wave. And look at this. This looks like a Kelvin wave now, 5 degrees north of the equator. It's not right on the equator. This is a little bit north of it, but it suggests at depth there is warm water almost to the Galapagos, pushing off to the east. In fact, let's look at this sort of in more of a time phase sequence. Upper ocean heat anomalies. This image really tells the story quite well. This is the West Pacific here. This is the East Pacific here. The blues are colder than normal waters. You can see a Kelvin wave last year around this time made it, that's warmer normal, made it across the Pacific, but then cold water came right back. El Nino, and well, let's say La Nina, is really, doesn't mean that there aren't Kelvin waves and that there isn't occasional westerly anomalies in the active phase of the MJO, but what it does mean is the inactive phase of the MJO and easterly trades dominate, and there's only these rare instances where you get Kelvin waves and westerly anomalies. But look at the amount of warm water that has been building up, and this is over the past 2 years, driven by those strong easterly trades. At some point, the trades are going to collapse, which we think they're doing now. You can see this here. So November, that's, or even in July, this is when this last cool pull build up. It held till about November, and you can see the warm water just steadily making its way across. Now the question is this a one-time event? Is this a single Kelvin wave and then we're done, like back in here, one and done? Or is there going to be a pattern of consistent Kelvin waves? Well, based on what we looked at from the previous models, where it looks like westerly anomalies are now getting entrenched in the West Pacific, the betting man would probably say it's not a one-and-done Kelvin wave. There's probably many more to come, and that would suggest the development of El Nino sometime later in the new year. Upper ocean heat anomalies, telling the same picture here. Back in January, there's your 1 Kelvin wave, cold water again. This is the upper 300 meters of the ocean between the date line and 100 west. Another Kelvin wave back in June, July, and then a long run of cold water. Then here we go. We're approaching the tipping point where warm water overtakes cold water. Just another graph showing the same thing we've been seeing before. All right, what's going on at the ocean surface? Marked changes here as well. All right, so what do we have here? We have Chile, Peru, South America, Central America, Hawaii here, the equator right here. There's the Galapagos. This is a stitched image, so they don't completely line up. You get the general idea. What we have is, well, cold water from the Galapagos the whole way across. This is the La Nina signature here, this cold water. But notice, warmer water is making its appearance in balls here along the equator. But even more important, warm water building along Chile and Peru. Yes, there's this little thread of cool water here, but the real thing is all this here. This used to be much, much, much colder. It's rapidly collapsing. There's no real cold water. This is the last of the really deep cooling from La Nina. It's as if it's been cut off from its source here in the East Pacific, and this is just getting dragged over by trades, probably enhancing trade winds on the date line like what we're seeing. But once that dissipates off to the east, it's all over, we suspect. Let's dig a little deeper. The trend for the past 7 days, sea surface temperature trend. Yellow's warming. You can just see it. Chile, Peru, even up into Ecuador, steadily warming in here, and now in parts around south of Tahiti and that area, a steadily improving pattern. I think this is not really like a Kelvin wave induced. This is more just the trades have collapsed here so the sun can start beating on the ocean surface, and there's not that upwelling thing going on. And so that is taking all the energy out of this East Pacific area and starting to warm surface temperatures here. And the backed off view, same sort of thing. Yes, water temperature is still cooler right here, but warming significantly, warming along Chile and Peru, pockets of warming along the equator. once that Kelvin wave impacts here, that really is going to cut the legs out of things, and we think a steady warming pattern will set up. So does the atmosphere sense any of this change? And the short answer is not yet, but it should be coming pretty soon. We're looking at the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. Tahiti in the Pacific, Darwin in the Indian Ocean or maritime continent. When pressure is higher over Tahiti, the index goes positive. We want to see it go negative. When pressure is lower over Tahiti, then the index goes negative. When El Nino is developing, pressure starts falling in the West Pacific. We have the westerly anomalies, but they certainly haven't made it to Tahiti yet. They're just getting their toe in the door, and the index is not indicating a significant shift yet, but we're keeping our eye on here because we expect at some point these numbers are going to start crashing. Anyway, today's value, 28.41. Look back here. We were up to 55.74. Now, we had a little bit in early December of some negative numbers, and there was another run a little bit in November. But still, this looks very much like La Nina. The 30-day average SOI is rising to 18.90. Where was it before? It was down at 5. So this is sort of out of whack with everything we're seeing in the ocean. And the 90-day average, 14.39, that's positive. We want to see all this stuff turn negative. The good news is the 90-day average is saying, oh yeah, it's steady state La Nina. But you and I know from looking at all the other data, well, there's a Kelvin wave coming, westerly anomalies in the West Pacific, all sorts of things are happening. This is more like the tail of the dog. And we're looking at the nose when we look at the westerly anomalies, and the dog wags the tail doesn't wag the dog. So this is a lagging indicator. Here's the 30-day moving SOI. Again, the neutral line is right here, right? So when you're above this, you're in La Nina territory. Clearly, we have been all January 2021. So 2 years of in La Nina territory. The downward spikes are the active phase of the MJO. We're expecting to see this at some point starting to fall. It's got a ways to go. So for right now, atmosphere somehow, at least most of the atmosphere from a Southern Oscillation Index, Tahiti is 140 west. Far West Pacific is changing. Tahiti isn't seeing the drop in pressure yet. I think it's all confined. If this measurement was being taken, I don't know, somewhere just, like barely in the West Pacific, I think you'd see a much different picture than this, but that's what we have right now. All right, so let's just get right to it. The forecast for the Nino 3.4 region, the official El Nino monitoring region, sea surface temperature anomalies. All right, this suggests, and when you're half degree below normal or less, and that's where we have been, down at about 1 degree below normal, La Nina territory, in the official El Nino monitoring region. Once we get to, this is January 15th, the model suggests temperatures rising steadily as by the time we get into February, we're out of La Nina and into neutral territory. And then as we get into, the July, August, September timeframe, into borderline weak El Nino territory. Now, this is the raw data. The PDF corrected data suggesting much the same thing. By, we'll say, the first week in February, we're into neutral territory, rising steadily from there. Now, this suggests dead neutral getting into the fall. But there's some other one little thing I want to show you. This is the sea surface temperature anomaly charts for January, February, March. And I know this is all really small, and I'm not going to bore you with looking at all these. But when you get to the June one, you'll just click it and see, there we go. And what does this suggest? Warmer than normal temperatures. That's a pretty clear hint of an El Nino, or at least a weak El Nino area starting to build. Now, this is the Nino 1.2 region. The official El Nino monitoring region starts at 120 west out to 170 west, right in here. So no warming temperatures in the official El Nino monitoring region, but with this starting to build, that is clearly way better than this with all this cold water, because remember, cold water does not support evaporation. It doesn't impart energy to the jet stream. All it does is support high pressure down here and here. Let's see. Yeah, that's the correct pattern there and there, which feeds trades here, which does nothing to impart energy to the jet stream. So the point being, 6 months from now, we're moving from here, theoretically, to here with neutral temperatures and warming temperatures in the east. That would be a step in the right direction. All right, so for right now, things are looking much, much, much better. The jet stream just roaring. Storm after storm after storm, building, pushing their way across the Pacific. Not necessarily swell-producing storms yet, more like weather-producing storms for California, which is great. We'll take everything we can get. But it looks like even a week from now, the pattern is then going to start shifting maybe off to the east a little bit. In fact, if you look at the long-range models, there's suggestions of high pressure starting to build over California, maybe starting January 15th, something like that, maybe a dry out starting, but not a collapse of the jet stream, just a little building of high pressure over California to sort of knock those south winds down and some of the precip. But it looks like the storm machine long term might continue to evolve and get stronger. This all suggests that we're in a way, way better place than we were 2 weeks ago even. Now, again, you're looking at a model a couple of weeks out, so we don't really know how this is going to play out. But the early indicators are that what I thought was going to happen maybe in early February is happening right now. Welcome to our new year. This is all good news. This is probably a better gift than what I could hope for. So we'll keep our fingers crossed, but certainly it looks like the new year is starting off with a bang. All right, if you enjoyed the video, give us a thumbs up. If you haven't, subscribe, ring the bell, you get automatic notifications. If you have any questions or comments, leave them in the video down below, and we'll be happy to answer them, try to explain whatever it is that yeah, I know it's a lot of data here and a lot to consume. So if you don't understand something, you know 10 other people are thinking the same thing. So we'll try to help you out. All right, that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching. Happy New Year, and things are looking good.